Hello everyone, welcome to the next lesson in matrices. This lesson begins on page 11 in your notes. And what we're going to look at today is how can we use matrices um, to actually solve a system of linear equations. Now you were solving systems of linear equations back in Math 1700. You may recall that what you had to use was something called Cramer's rule. And actually it shows right here, there's your Cramer's rule. And that involved calculating determinants on your calculator. Well, it was a kind of a long method. When you see how you can use matrices in your calculators to solve a system of equations, I said in the last class, and I'll say it again, you'll never use Cramer's rule again. So let's see how this works and how we do it. The main thing is make sure you know how to type in a matrix on your calculator. You're actually going to have to type in two matrices for this, what we're doing today. And make sure you know how to get the inverse of a matrix using your x to the minus 1 button on your calculator. So let's look at a system of linear equations. Here's a simple system right here. Now, that's two equations and two variables. The variables are x and y. The a's, b's, and c's are supposed to be just numbers, just regular real numbers. Well, what we can do, we can take a system of equations like that, and we can actually write it as a matrix equation. All right, now this step I'd like to see in your calculations. Show the matrix equation that you're going to use to actually solve the system. And here's what your matrix equation looks like right here. Now, the first matrix you will notice for a 2 by 2 system, the first matrix is a 2 by 2 matrix. And that's what we call the coefficient matrix. You get its elements by looking at the coefficients of your x's and your y's in your equation. The second matrix is actually what we call the variable matrix, and that represents the x and the y that you're trying to calculate. That is your unknown. That's what you're trying to figure out. That's what you're trying to get by itself, just like you would try to get the variable in a linear equation by itself. And that's your strategy. And then you have your equal sign, of course, right here. And then the final matrix is also a 2 by 1 matrix, the same as the variable matrix. And that's called the constant matrix. And that matrix comes from the numbers, the constants, that are by themselves on the other side of your equation. So that's what your matrix equation is going to look like. Now they're saying down here, if you look carefully just down below, they're saying let's call that coefficient matrix A. All right, so that's just A. And let's call the variable matrix X. Now they're calling it capital X, so we can call it small x if you like. Just remember that that's the unknown. That's what you're trying to calculate. That's what we don't know. And then you have your equal sign. And then C, of course, is your constant matrix. So there's the equation that you're trying to solve. Now, if A and C were just numbers, and if X was just a single variable, you'd divide both sides by A. But you can't do that with matrices. You cannot divide with matrices. But you can make it disappear. You can make it vanish or turn into the equivalent of the number 1 by multiplying it by its inverse. All right, so what we would do here is if we multiplied both sides of this matrix equation on the left, because remember, it's important, the order. You have to multiply them in the same order on both sides. So you multiply both sides of your matrix equation by A inverse. And of course, now what happens to this thing? What happens when you multiply a matrix by its inverse? You get the identity matrix I, which remember is the equivalent in numbers to 1. So it's like 1 times x equals, and on this side you'd have your regular number. So there's the matrix equation you're solving. That's what you're trying to solve. So you would multiply on both sides of your matrix equation on the left by A inverse. And here's the equation, ladies and gentlemen, right there in bold letters. There is what you're actually going to use to find out what the numbers in the variable matrix are. What is the x and what is the y? And it's so simple. It's such a very, very straightforward technique. Basically, you're just typing everything into your calculator, and your calculator is spitting the correct answers back at you. Beautiful, beautiful, beautiful. The only work involved in this is actually typing the matrices into your calculator and then knowing what to type in afterwards. So on page 12, right, they've got some nice examples there. Let's have a look at this first one. Here's a system of equations, two equations, two variables. This one is actually fairly easy, fairly short to go ahead and solve. So what we'll do first is write it as a matrix equation, and that part is vital. You need to do that. So look at the coefficients in front of the x's and the y's. Make sure, by the way, first that your system is set up correctly. Make sure your x's and your y's are lined up perfectly over each other. Make sure the constants are also lined up. Even the equal signs must be lined up over each other. So the coefficient matrix would be 2, and in front of the y you have -1, and then 5, and then -3 is your other coefficient in the second equation. So there is your matrix A. That's what we're calling A. We're going to multiply that by the variable matrix, which in our case, what are your two variables? Well, the first variable is x and the second variable is y. Okay? And then we have equals, and then we write our constant matrix, which is actually 7 and 18. All right? Now, by the way, if you wanted to actually verify that this matrix equation is the same as the system of equations you started with, remember how you multiply matrices. You would go across the row in the first matrix, so 2 and -1 would get multiplied by, well, there's only one column in the second matrix, so you would have 2 multiplied by x, and by golly, look at that. And then -1 multiplied by y, and by golly, look at that. And it's equal to this number here, and by golly, look at that. That's your 7. And if you multiply 5 and -3 by x and y, you get a result of 18. That's your second equation. And that's why these are equivalent. All right, so in your calculator, here's what you would actually type. X is equal to A inverse multiplied by, that's a big one, multiplied by your C. Okay, we're calling that C. Now, let me show you what I've got here. I managed to get my emulator working. Okay, now this is the Texas Instrument. Now this is actually an older model, the TI-83, but the matrices work exactly the same way as they always did. So I'm going to do this one very quickly for you using this calculator. Now I'll turn the calculator on first of all. Okay, and let me see. Do I have any matrices typed in there already? No, I don't. Okay, so there's no matrices in there. So what you do to type in your matrix with this calculator is you go second matrix. Now the Casio should be similar. If you have a Casio, please make sure that you know how to do this with your Casio. Now, of course, here's all the different matrices I can type into the TI-84 or the TI-83. You can call them anything you like. This first one, for example, is called A. The second one is called B. And the third one is called C. You can use A and B. That's fine. Go over to Edit because you're going to edit your matrix A. So hit Enter now. And the first thing you have to type in is what are the dimensions. So it's a 3, enter, or sorry, not 3. What am I doing? It's a 2, enter, 2, enter. And you'll see what pops up on your screen. This is matrix A, and you can see 2 rows and 2 columns. So what we'll do now is one at a time, we'll just type in matrix A. 2, enter. -1, enter. Remember, if you're using the TI calculator, the minus button is not negative. You have to hit the negative button down below next to the decimal point. So -1, enter. And then I type in a 5, enter. And a -3, and an enter. And there is my matrix A. So it's all typed in. Now you can quit that. You can go back to a blank screen. So what I'm going to type in now is my second matrix. All right. So remember now, the equation that you're solving is A inverse multiplied by B. Now, well, you can call it C if you want. I like picking B. But you can call it whatever you like. It's okay. All right. So second matrix once again. I go over to Edit again. Now this time I'm going to type in my matrix. I'll call it B, but you can call it C if you like. So I'll just hit the number 2 for B. And now the size of my matrix B, remember, is your constant matrix. So that's a 2 by 1. So 2 rows, 1 column. And now you type in the two numbers, whatever the numbers are. Well, in our case, it was 7 and 18. So 7, enter. 18, enter. And there's your matrix B typed in. So now you can quit once again and go back to a blank screen. Your matrices are still in the calculator. All right, so now, believe it or not, That's all the work to it. That's basically all you had to do. All I need to do now is bring up the equation A inverse times B. So I go second matrix once again. Now I'm not editing the matrix this time. I'm actually going to use the name of the matrix. So notice that number 1 is highlighted. So I can just hit number 1, or you can hit enter, and the matrix A comes up on your screen. Now hit your inverse button. That's important because you have to take the inverse of that first matrix and then multiply. And now second matrix once again, and the second matrix we call it B, and you can see the dimensions of both matrices over there. So you can just press number 2, or you can use your arrow to go down, whatever. And now notice what's on my screen, A inverse times B. And now all you have to do is press enter, and voila, there is your X and there is your Y. You see that? That's all there was to it. Now, when you do get your answer, notice now it's 3, -1. It's important to write your answer looking like the answer to a system of equations. All right, don't just write down that matrix, that 2 by 1 matrix. Actually, write down that the solution is x equals, what was it again? 3. Okay, so x equals 3, y equals -1, and that's how you can give your solution, or you can give it looking like a point if you want. But in general, everybody, it's really, really easy. And it doesn't matter how many equations and variables your system of equations has. It can have 2 equations, 2 variables, 3 equations, 3 variables, whatever. This technique works perfectly with all of them. So I see some more exercises there. Now you've got example number 2 here. I'm going to leave those for you to try. Make sure everything is lined up perfectly. First of all, x's, y's, z's, equal signs, and constants. Okay, the first one's okay. The second one. Look at that. They're trying to trick you here. So what you need to do, the first equation, now you can just switch around the x and the y. Let me get my marker. You can switch around the x and the y if you like. The second one starts with an x. Oh, and look at the y over here. You better move that over. Right there, okay? And for the third equation, that's kind of messed up too. So you better put everything in order. Now you can call that third one -2x, and bring your y over. It becomes a -y, and plus 7z. And then you had to bring your -33 over, and it becomes +33. So that's the equation you'd use there, okay? So anyway, I'm just going to get you to practice these on your own. Practice each system of equations for the unknowns. It doesn't matter if they're decimals. You can even use fractions in this method. And what do you think of Kramer's rule now? I thought so. So try these other practice ones as well, as long as you make sure that they're all in the right order and that you're typing them into your calculator okay. You won't have any problem. And by the way, if you happen to have the Texas Instrument calculator, you can even solve a system like this. Look at that. 4 equations and 4 variables. When you're solving a system of equations, however many variables you have, you must have at least that number of equations as well. So if you had a system with 4 variables and 3 equations, well, sorry, that's not solvable. Okay, you'd have to leave that one. And there's another 4x4 system. Like I say, if you have the Texas Instrument calculator, go ahead and try those. All the solutions have been posted, the full solutions in D2L. Please make sure you check them to see if you're doing these correctly. If you have any questions, make sure you get back to me. We've got one more lesson to go now in this course, and basically it's exactly what we've been doing today. It's solving systems of equations, but with applications, in other words, work problems. So that's it for this video. I'll see you again in the next lesson. Bye-bye for now.